What tasks should I be most concerned about? A fully networked schedule with float values provides all the information we need to determine the critical path. A critical path, as the name implies, is a pathway through the schedule, starting with the earliest task that is not yet completed and ending with the final task. As we trace a pathway through the network, we are looking for the longest path with the least amount of float. Let's find the critical path in our schedule. Now that we've identified the critical path, let's take a closer look at how to manage this schedule. Task E is the longest task in the schedule and is also part of the critical path. Assume that overtime is authorized for Task E to reduce the duration of the task from 9 days down to 4. What happens if the contractor implements this change? Will the project finish early? If so, by a full 5 days or some lesser amount? Or alternatively, will the project finish on the originally planned date, but Task E now has 5 days of float? Let's implement this change to our network schedule to see which is the correct answer. Task E currently ends on a Friday. If we reduce the duration by 5 days, it will end on the previous Friday. As we pull in the end date of our schedule, we unfortunately run into Task G. The reduction to the end date of the project is only 2 days, not the full 5 we were hoping for. This change to the network schedule has now shifted our focus in a different direction. Calculating new float values, we can see that the critical path has shifted away from Task E to Tasks D and G. If the schedule network is set up properly, where every task is linked to at least one other task, the critical path can dynamically shift.